Class attendance enabled. Okay, sorry, I enabled it for IT plus CS. This is actually CS plus AI. Sorry. Yeah, this is yours is enabled it too. Still 48 only. 49 now. So we are just touching 60 now. So one announcement. Basically, you guys have some engagement today at 4 p.m. So we will do this on. I think 4 to 6 is the most chosen slot. Just a minute. Mm, yes. So 4 to 6 p.m. on Thursday is your lab. Okay. I'm assuming that that slot is free for you. Okay. I have not checked your timetable, but I'm assuming that slot is free for you, and maximum people have opted for that slot. So your lab will be 4 to 6 p.m. Number one. Number two, the problem with online GTP is that I can neither download your submissions nor can I actually see your emails, even though you may have registered with your official email. I only see your names. I don't see your roll numbers. So it's very difficult for me to you know it has to be done manually. Every person's uh, code you'll have to open and then match your name against a roll number list, and then put your marks in. So that will be too hectic, especially because I'm not asking the TAs to do it like this. So the platform we'll use will be Google Classroom only. You'll have to submit your code on Google Classroom. You can use online GDB as a way to solve it, right? I mean, that will actually be a good thing to do. If you want, I can also create a problem on online GDB, and I'll put some test cases there. So you can probably test your code there with the help of test cases. And once you are sure that this is the right code, that code you'll have to submit on Google Classroom. That seems to be the midway out to me.
ये क्लास है इतना सुन आज लैब है मेरा सेटिंग तो बंद
Uh,
है ये नंबर
someone's mic is on. I think Humanshu. Okay, so that seems to be a midway out. I can create the problem on online GDP. It's because the advantage is I can put in some two, three, four test cases there. So what happens when you guys submit the code? Do you see which test cases passed and which test cases failed? Because for some guys the test case actually failed. They wrote hello world in small instead of capital, so they would have seen test case failed or something like that. So the only reason I'm asking this is that can you actually realize that where you are going wrong? If you see the test cases that are failing, then you can modify your code in order to pass those test cases. So if you get that kind of information on online GDB, then I can create the problem there itself. But if you just see number of test cases passed are one, two, or three, something like that, without any other feedback, then it's kind of useless, right? Uh, so what is decided is that the submissions will be on Google Classroom. Problem, I can either send it to you over email or I can create it on online GTP. Okay, in fact, I'll probably send it to you guys over email only because everyone has not yet joined online GDB itself. So it's better to send it over email, and you can use online GDB or some other platform that you want. So there is no restriction of platforms this time, right? You're not supposed to do it only over Bash, something like that, because there won't be any demo. So do it wherever you want. Just make sure that the code that you finally submit is correct, right? In the previous case when we had the assignment, many of you actually sent maybe a stale version of the code, or at the time of zipping you guys did not did you made some mistakes. This time just don't zip anything, simply put the C file. uh, and Because zip might actually be creating an issue. Some of you may are, no, are some of you are not really that well aware of zip. So simply upload your .c code file. That is enough. Okay. Anything else about the lab? No, right? And uh, so my planning till now is something like this. How many weeks we have left? Four, right? Including this one. So what we can do is we can have two of your assignments like this, submissions without demo, and then we can have two of those, two or at least one of that 3 hour lab. Okay. We will call that 3 hour lab as a lab exam. Okay. And I'll just probably give it slightly more weightage, and that exam will be compulsory for everyone. Okay. Even for those students who are not able to attend that, I will make sure that there is some alternative arrangement, but basically we will consider that 3 hour lab as a kind of lab exam. So I'll put like 30% weightage for the exam, and then 70% we'll count from the labs that we are going to have. Okay. Okay, guys, so let's start. Today, we are basically covering now the last part of conventional programming that any conventional programming subject should teach you, and that is file handling. Okay, so when I say conventional, because file handling is one of the most essential tasks that you will have to do, irrespective of what language you choose uh, to to code in future. Yeah, this is a common skill that you need to acquire, the skill of being able to do file handling. Now, different languages have different types of libraries for it, but almost all languages will have at least a basic library for file handling. So you need to know what that library is, and because otherwise it will be very difficult for you to program. Okay, so let's start the lecture. Uh, who are my volunteers for today? Okay, Pranav is here. Thank you. Just a minute. CSAI 10, right? I think I remember your.
Yeah.
Very good. Pranav is CSAI 10. Anyone else? Just Pranav? How
That's
many
fine.
people? Yeah, how many people do we have? 72. There was 72. There's Ayushman is there. CS 24. Just a minute. CS.
Yes, 24.
Yeah, yeah, yeah. You put it in your name. That is good. Uh, huh. Anyone else? I'll be happy if there are at least three. I'm fine with two as well. But okay, so let's start with two only. Again, I mean, if anyone else is interested, just tell me right now. Or okay, so the lecture that we have today is the first part of the file handling lecture. Um, sorry for the delay of the second part. I finally managed to upload it yesterday night. There are so many things that I have to manage. But second part is there as well. Please watch it. It's I think around 20 minutes of time that it will take. So just find some time today, or in fact today you will have that time, right? I mean 3 to 4 you will be free. So just keep that time for watching that lecture. If at 4 o'clock you can watch your regular lecture, or regular whatever it is talk, and but in that 1 hour time, 3 to 4, try to watch that lecture, okay, for tomorrow. Okay, so let's start then. And as I've already said that next week lectures will be live lectures, because they'll be about GDB, and they'll be about problem discussion. So pick some problem. The other batch has already picked up two problems. They would like me to talk about the code of linked list and uh, structure sorting. They have picked up two programs already. So if you guys have any specific preferences for our we have two lectures, by the way, for problem discussion. So if you guys feel like this is the problem we would like to discuss, please do tell me beforehand. Okay. uh, Clock code, what clock code? Okay, okay, that static variables, is it the one which uses static variables for program execution? How many times? Okay, 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 got it. That we can discuss. um, think if there is any other code that you would like. Try to pick some other code, because uh, these recordings will go online anyhow, right? So if I discuss something with the other batch, you can anyhow watch it later. So try to find some other code so that both batches are benefited, right? So that will be the best way to utilize it will be like 4 hours of problem discussion, 2 hours with you guys and 2 hours with them, and then you can watch each other's session. Okay. Okay. So Pranav, are you ready? We can, Pranav and Ayusman, you are ready. You can start.
I
Yeah.
can start. Um,
Okay, go
so
ahead.
in a text file, uh, basically ASCII text is stored, but in a binary file, if you open it in a text editor, then you will basically see random letters that you will not be able to read, and you can see the hexadecimal value if you use a hex editor. So that is the difference between a text file. Text file is easily readable for us, so that is why we uh, mainly use it when we have to write something. We just use the normal text file where binary file. Uh, that is the difference.
Yeah, so like he said, text files are basically ASCII, which is just numbers, characters, ABCD, and symbols like plus, minus, bracket, so on. And binary files are actually super, like a superset of text files. So binary files contain other random characters. If you have opened like DLLs or something in Notepad, you might have noticed that there are like question marks and stuff. So these are basically binary files. So the difference between text files and binary files would be the additional characters, which are additional data which is present in binary files. Yeah.
So so basically that part, let me just rephrase it. What happens is something like this: in a text file, the idea is that it will be opened up for viewing by human beings. That is the idea. Okay. And when I say viewing by human beings, it means that when I open up that file, I should be able to read the text like A, B, C, D, E, F, G, S, 0, 1, 2, 3, plus, minus, comma, full stop, so many things, right? So this is the idea, that when I open a text file, it should be human readable. And the convention is that in order to make it human readable, see, at the end of the day, you are only storing some bytes in the file, right? You are storing some 0101 patterns, and 80101 patterns constitute a byte. So basically, whatever you store in a file, it is nothing more than a sequence of zero ones and zero ones. What differs is how do you interpret them. Okay. So when I talk about a text file, and assuming that they've been the encoding that has been used is ASCII, then what happens is each byte in your file it represents a character in your character set. Okay, the ASCII character set. Okay, now the ASCII character set has all the common characters that we use: A, B, C, D, 0, 1, 2, 3. ABCD, both capital as well as lowercase, and then the punctuation characters. So they are there. But it's a very restricted character set. But still, most of the time we only interact with each other using that same character set. So as long as you're not using any other character which is outside the ASCII character set, it is very likely that your file has been encoded using the ASCII character set. So what it means is each character that you typed, it has been saved as 1 byte in your text file, and when your text editor opens it, it simply starts interpreting it in the same fashion. That let us say if this is 00 something something something, it is the binary equivalent of 65, and 65 means capital A, so I'll show you capital A on your screen, something like this. But when it comes to the binary files, there is no interpretation that is attached to it. Okay, it's like you to you, it's created by you. You really figure out what it is. I know the operating system doesn't doesn't actually get involved in it at all, right? It says, okay, these are a sequence of bytes, you interpret it the way you want. Okay, so for that is why I gave you an example in the slides, that let us say you wrote an integer and a double and a char inside a binary file. So it will take 4 plus 8 plus 1. It will mean 13 bytes of data was written to a binary file. Is it text file? Yes, that is right. So the what you can do is just open your docx file in Vim or Notepad and see what do you see. Okay, that will give you an idea. Uh, So I'll tell you why it is a binary file and why the others are text files. So because a docx file is essentially a binary file, even though whatever it is storing is text, it is stored in a binary format. Why? Because there is something known as rich text format. Okay, so the files that it creates, they are rich text files. Okay, this text, what do I mean by rich text? They are not only text, there is some other information attached with it. For example, there is a font attached with it. There is formatting like italics, bold, underline. Okay, there can be images within your text, within your Word file. There can be tables within your Word file. So this is not represented in simple text. Okay, simple text is everything that you write in Notepad. That is simple text. Then you save it. It gets saved as a simple text file. And this is what you have to understand. Whatever you cannot do in Notepad, okay, if there is any editor that allows you to do that, it means that it is not going to save your file as a simple text file. It is going to be saved as a binary file. That is the idea, right? So this is where I was coming to, that in binary files, it is up to the program, okay, to store the data whatever way you want. Okay, it's the operating system doesn't care. Okay, it is for the operating system, it is just a sequence of bytes. Now you interpret it the way you want. Okay, so I was taking the example of writing 13 bytes. Okay, so let us say I wrote an integer to a file, and then I wrote a double to a file, and then I wrote a character to a file, char. It will take a total of 13 bytes. But when you open up that file in some hexadecimal editor, so first of all, the editors that we use for seeing the content of a binary file is not our typical Notepad. If you open it in Notepad, what will really happen? Why do you see those question mark and those weird characters? Because Notepad tries to interpret these 13 bytes as 13 different characters, right? Because it is a text file, and you know it says, okay, the first byte should be this character, the second byte should be that character, the third byte should be that character. And when you actually interpret it in terms of ASCII or some other encoding, something weird appears on your screen. This is why when you open up a binary file in a text editor, this is actually what is happening. Each byte is being interpreted as a separate character, even though the first 4 bytes are actually an integer. the next 8 bytes are actually a double, then the next byte is a char, right? But it is not in being interpreted in the same fashion by your text editor. For the text editor, it is like each character, each byte is a different character, and that is why those weird characters appear, right? So the idea with a binary file is that you store data in whatever way you want. Okay, the operating system has nothing to do with whatever it is, right? It basically says I have a file of size x bytes. Now exactly how do you interpret those x bytes, it's up to you. Okay, and that is why there is, you have the onus of coming up with a format. You say that the first thing that I will see in the file is an integer and it means this. The second thing, the next 8 bytes in the file is a double and it means this. The next byte in the file is a char and it means this. So now you can see that each program can have its own data format. Okay, and as long as you use a compatible format to read the file, you can interpret the data. But if you try to use some other program, and some person actually did that, I think that person, some student actually tried to write a file using some other program and then read it using that list reader program that I sent you guys, and it was doing something weird. That is exactly the reason, because the format that list reader expects, a file will only be, you have to build a file that follows that format. If you don't build a file that follows that format, something weird will happen. And this is what happens when you try to, let us say, open a mp3 file in Word. They are both binary files, okay, but Word will try to interpret it in the docx format. It will expect certain bytes to mean certain things, but in mp3 the data is stored in some other format, okay, that is only interpretable by an mp3 player. It is not interpretable by doc, by Word. Okay, so this is the major difference, and this difference has nothing to do with C. Okay, whichever programming language you use, you will have to make this decision. Whatever data I am going to store in the file, shall I store it in textual format or shall I store it in binary format? That is a decision that you will have to make. Okay, any more questions on this? Because this is the core part of this lecture. Everything else is basically C related syntax, but this is the core part. You need to understand the major difference between a binary file and a text file. So if you have any questions, please ask. Okay, so then I guess you guys can move ahead.
Me, sir.
So as
Yeah. So we relate binary files to a file containing zeros and ones, or the format that we have to decide. I mean, in the Word file, we don't see zeros and ones. We just write what we want, any string, any integer.
Yeah. So what happens is, try to open a Word file in Notepad and see what do you see. What happens is something like this. Uh, Word has its own format. Okay, so essentially, whenever you write something in Word, as I said, there is so much of information that has to be stored. So, for instance, I'm pretty sure even if you create a Word file with just one word in it and you save it, most probably it is going to take something like 1 kilobyte of space. Okay, even though all you need is probably 4 or 5 or 6 bytes, right? But it will take 1 kilobyte of space. Why? Because so much of hidden information has to be stored, right? What is the font size of your text? um, what is the font that you used, whether you used anything bold, italic, underline? So how do you store this information, right? So you have to come up with a format. You say that this is my actual text, from character number 0 to character number 3. It has to be represented in font size 16. From character number 4 to character number 8, it has to be shown in font size 15. Character number 6 to 9 has to be italic. Character number 10 to 15 has to be bold. So this is some information. Okay, it has to be stored somewhere in your docx file, and this is what it is all about, right? That Word has its own way of managing this data. There is some format, some binary format it has decided that this information will be stored here, this information will be stored here. And when you open a docx file in Word, Word understands which byte represents what information, and it can render that document on your screen. Okay, whereas in Notepad, whatever you write, that is simple text. Okay, you can open it up on your terminal also using cat, right? It's so the interpretation of a text file is different from the interpretation of a binary file. Binary file is application specific or program specific. Okay, whereas text files are generic. Okay, generic as in, um, it's the only thing that you have to know is the character encoding, whether it is ASCII or Unicode. In Unicode, whether it is UTF-8, UTF-16, things like this. But as I said, 19% of the time, if you don't know the encoding of your text file, it will most probably be ASCII. Okay, uh, so that is the difference between a text file and a binary file. Any more queries, or we can go ahead? Okay, Pranav and Ashman, you can go ahead.
As said that in a text file, uh, it stores it as a character. So the integer one will be stored as a char, so it will 1 byte.
Yeah, that's correct, right? So there might be some trailing characters like a slash n or something, but yeah, we can simply ignore that. But it'll basically take, if there are x characters in the text file, you assume that it will the size will be x bytes. That is the idea. If you are using a ASCII as the encoding. Any questions on this? Okay, then you can go to the next question.
I think in binary file it should store 4 bytes. It should store it as an integer.
Yes, that is the answer. So now can you understand that if I am storing 1 as a character? Yeah, go ahead.
So can you difference between these encoding types? You are saying ASCII, UTF-8.
Yes. So essentially, this is not something that we really need to know right now, but let me just tell it out to you guys anyhow. So ASCII, you know that ASCII is basically 7 bits, right? You represent your so all your characters which are there in ASCII, they have a 7-bit code associated with them. The problem is it's too restrictive, right? I mean, this means that only 2 to the power 7, that is 128 characters you can represent. Now this was fine until we were only dealing with English. Okay, the English language only has certain number of characters, right? 26 um, capital characters, 26 small characters, and then you have 10 digits, then some punctuation characters, and some control characters. So that was just, that was, for that 128 was enough. But the moment you start thinking about other languages or a more advanced set of character set, right, where you have so many different symbols, even within English, if you go to Europe, right, they have this I forgot the actual name of it. Basically, you represent a character with some notations, some vocal notations over them. Okay, I forgot really. So have you seen some E's which are having a different kind of uh, I really forgot the name. Are they called
Yes,
phonemes?
The
I
Yeah,
in German
understand the
languages.
yeah, yeah,
yes.
yeah. Yeah, like someone has written this, right? um, so this cannot be represented using ASCII, for example, because there is no character code for it in ASCII. So if you want to write this in a text file, the character encoding cannot be ASCII, it has to be something else. So this is where Unicode came into, right? So Unicode is a different character encoding standard, which stores data in more than 1 byte. Okay. So then there are different standards that are associated with Unicode. There is UTF. The most common ones are UTF-8 and UTF-16. So what happens with UTF-8 is that it will actually try to store as much as possible. So whatever text you are going to write, the minimum amount of space, it will be like 1 byte for one character. But for certain characters, if you are phonetic symbols, right? Phonetic symbols. So they are these characters have a phonetic interpretation attached to them, especially in Europe, for example. So anyhow, UTF-8 will try to store as much text as possible in 1 byte, but for certain characters it can go up to 2 bytes or something like this. I still don't uh, remember everything. UTF-16, I think it is guaranteed that every character will occupy two bytes of space. UTF-8, I think it can occupy 1 or 2. I have to go and check the standard. But the idea is that now you're not restricted to just 1 byte. Okay, ASCII has fixed character codes for all the characters. UTF-8 and UTF-16, they allow you to extend your character set. That is the idea, that you can now encode more characters in your text file. Just read what is UTF-8 and UTF-16, the differences between the standards. Okay, but the idea is you can represent more characters. Okay. Yeah. So, any other queries, or shall we move? Okay, guys, you can move ahead.
So the first parameter in fopen is the file name, and the second parameter is how you open that. If you want to only read the file, write the file, or append the file, for that the symbols are R, W, and A. So the difference between W and A is that with W, if the file is there already, it will erase the file and create a new file, whereas with A, it will append to the file.
So, there is a homework where I ask you guys to check out the possible access mode strings. But do you understand the concept of these access mode strings? That is the only thing that you have to understand. Everything else you can open the man page of fopen and check out. But you should understand what the process, that there is a file pointer that gets created, and you have to pass the file name and this mode, the mode in which you want to access it. It could be text mode, it could be binary mode, it could be for reading, or it could be for writing. You can do both also, by the way. I think uh, the example
It is
associated.
R plus W plus B.
Yeah. Yeah. So basically, the example that you would see for the uh, lecture that I uploaded yesterday, that is using these plus symbols. Um, yeah, I will not actually go into the details of what these plus symbols are. This is like very simple. The only thing that differs is so R plus and W plus, they basically allow you to do both. They both allow you to read as well as write. It's just that with W plus, if the file does not exist, it will be created. With R plus, that will not happen. With W plus, the place where you can add stuff will be towards the file pointer by beginning is at the file access position is at the end of the file, whereas with R plus it is at the beginning of the file. So these are some technical details. You can open up the man page of fopen, and it will tell you like where exactly, what is the difference between these 2 or 3 modes. But that is fine. You can, it's like a 10 minutes job. Just open the fopen man page and read. The thing that I want you guys to understand is that whenever you are going to open a file, the decisions you are supposed to make are: number one, whether I am going to read write a text file or a binary file, and number two, what are the things that I am planning to do, if I'm just planning to read it, don't try to open it for writing. That is the idea, right? Because at the operating system level, if you just want a read access to a file, this is something that you will study in operating system. Multiple programs can simultaneously read a file. There is no problem with it, right? So even hundreds of programs can simultaneously read a file. There is no issue with it. You will not be disallowed to do that. But if even one program wants to write it, okay, then some management has to be done. Okay, uh, other programs have to wait, and then only the write can happen, or the write program will have to wait till there are other programs who are reading it. So the idea is concurrent reads. Okay, concurrent reads are possible, and they are that is why, you should not open a file with, let us say, R plus or with W, unless you are absolutely sure that you are also going to write it. Okay, if you know that the only thing you are going to do is read it, then just open it in a read mode. Don't open it for writing. That is efficient. That is the only idea that you should understand from these access modes. That number one, whether I should whether it is a text file or a binary file, and number two, whether I really need to write it or not. If I don't need to write it, then I should open it in a reading mode. That is the only thing you need to understand. Okay. Any doubts? Yeah, go ahead.
So can you once again explain the difference between R plus and W plus? Actually, my network was.
It's okay. You can open up the F open page. In fact, let me just open it, guys. Open it for you guys, and I'll show it here. Just a minute. This is what I'm telling you. Just open the man page and. Just okay. So this F open is different because this is max F open. Um, if you actually open it in Ubuntu, it will also tell you about the plus thing. But basically the idea is this, let me just tell you. With plus, so when you do R plus, it means that the primary thing you want to do is read, but you might also want to write it, right? And when you do W plus, is that it means that the primary thing you want to do is write, but you might also have to read it. So there are some slight differences. Whenever you open a file for writing, the default is that, let us say, if the file is not already present, the operating system will create it for you. Okay, so if no file of that particular name is found, operating system will create a new file for you. When you try to open a file for reading, that doesn't happen. If the file is not present, you will have an error that this file doesn't exist. So the same thing applies to R plus and W plus kind of stuff. That with W plus, even if the file is not there, it will be created. With R plus, it will not be created. That is the idea. Number one. um, it's like this. If you watch the third lecture in the series, okay, that is basically 9.3, you'll get to know that when a file is opened up for read or write, there is a file access position. Okay, so which is the next byte that you are going to access. In this R plus and W plus, that is where it differs. Okay, with R plus, the file access position is put at the beginning of the file, whereas with W plus, it will be at towards the end of the file. Okay, and that has more to do with how do you actually read or write stuff. When you are trying to write a file, it assumes that you're simply going to write something towards the end. When you're going to read a file, it assumes that you're going to read from the beginning, something like that. Let me just see if I can. mm, just a minute. Ah, let me share this screen. Application window. Can you guys now see my VM, Ubuntu VM?
No, sir.
Oh, okay. Uh, Let me reshare it. It shows me that so I've shared a window. What can you see
Yes,
something?
sir, now it is visible.
Okay. Okay. So this
Yes,
is
sir.
what I was saying. This is what I was saying. If you open the man page for fopen, it will actually tell you all these things that the stream is positioned at the beginning of the file. The stream is positioned. Oh, sorry, it is at the beginning itself. Oh, sorry, I thought with W it should be positioned, I think, towards the end, right? Ah, so even I don't. Oh yeah, sorry, that is for append. I forgot. Yeah. So this is there in the homework. You have to find out the difference between write and append. I was actually um, whenever I spoke for W plus, that was basically for append plus. Yeah, that is right. So okay, let me tell you what is the difference between write and append. Append is something when you add something to the end of the file. Okay, do you understand the word append? That is the same meaning in the English language. That something is already there and you want to add something to it, right? That is when we use the word append. So there are actually three major modes: R, W, and A. R, uh, W, and A. And W and A are basically similar, with the only difference being with W, whatever if you open a file with mode W, um, if the file already exists, the content will be truncated, right? It will be everything will be overwritten. But with append, it will not be overwritten, but you can allow you can add stuff to the end of the file. That is the only difference between A and W. That appending, right, this is what it says: open for appending or writing at the end of the file. This is the idea of append. And so whatever I was telling you was basically A plus. Okay. The initial file position. Okay, so even I don't remember all these things. Sorry for that. So I don't think in any of these it is positioned at the end, is it? Huh. Okay, it is always appended at the end of the file. And that is why I told you, right? Just this part of text you have to read, and then you will understand what mode is going to do what. That is only thing that you have to read. Okay. And if you are doing it for a binary file, you just have to append a B to it. So instead of R, it will become RB. Instead of A, it will become AB, things like this. Okay, B is just a mnemonic for binary. Okay. Yeah, sorry, even I have forgotten so many things out of it. Yeah, so it is never positioned towards the end. It's always positioned at the beginning, from what I can see. But this is the only part you have to read, right? I mean, just read this much of the fopen manual, and you will get to know what are all the modes. Just this much part. And you don't have to remember this. That is the idea. Whenever you are writing code, just do man fopen. This is what I did, right? Man fopen, and then this will come up. So you don't have to remember all these things. Just open it up and can check it out every time. So is this fine, guys? You understand this? Shall I stop sharing this screen? Okay. Okay. And make this a habit, right? Reading man pages. This is a very good habit. If you can inculcate this habit, it will be very good for your programming as such. Okay. Yeah, you can continue, guys.
The equivalent to
Okay, so
printf is fprintf. I think the difference between fprintf and fwrite is that fprintf will write it in a normal text format, while fwrite will write it in binary format.
Yeah, that's correct. Any queries, guys? Okay, and then there's like a parallel question, for read part. You can go ahead, actually.
Okay, so like
Is
we have
F
F.
getters.
Yeah, I
Go
can. I
ahead.
think Pranav, you can take this one.
Yeah. Okay, so just like we have fprintf for instead of printf, we have fscanf instead of scanf for reading. It's basically the same way you do input output from the terminal, basically, but just you need to add f in front of the word, whatever. Yeah. Fread is like for binary data. So if you want to read one character or something like that, you'll use fread. Uh, However, if you want to read uh, according to some format which you already know, like if you have a list of numbers and you want to read those, and the numbers are stored in, let's say, ASCII, then you use fscanf. Yeah.
So you guys understand that basically for binary input output you have this f read and f write, and for character input output, um, f scanf and f printf. But again, f scanf has that same limitation that scanf has. So if you're reading a string, it will actually stop after it sees a space. So that is why you can probably use f getters, okay, instead of fscanf, similar to how we use fgetters for or getters for taking string input from the console. So all those same problems are there with fscanf as well. Okay, it'll, if you have a string where there is a space, it will not read the whole string. It will just truncate where it finds a space. But yeah, other than that, if you're sure that your inputs do not have spaces, or that you want them to be like that, then yeah, fscanf is a good option. Okay, what is it then we have done, right? Okay, handling files using a C program. The the answer to this is basically, you guys are doing this, right? Competitive coding these days, and many a times, in fact I think almost all the time, when you see the sample input output, it will be like this only, right? I mean, they'll tell you that uh, I mean, this used to be in my days. I'm a bit uh, uh, I'm not in touch, but when I used to do competitive coding, the input used to be like this, that first line. Okay, let me get to that. So input used to be something like this: the first line will have the number of test cases, then let us say it is n, then for each test case, whatever is the input, let us say you need three pieces of input. So then the next three lines will have the first test case, then the next three lines will have the second test case, then the next three lines will have the third test case. It used to be like this. I'm not sure what is it in today, but this used to be how competitive coding worked, that you will be given input in terms in an input file, and you will have to produce output in an output file, or maybe on console. That was fine. You probably might also produce it on the console. So this is where you need something like file handling in C, that many a times when you will actually go and write code, you will be expected to take inputs from a file, and you will be expected to send outputs to a file. Okay, that is why you need to know file handling. And fgetters, guys, it's very simple to saying um, fscanf percent s. Okay, that you can also take string input with scanf, right? The specifier is percent s, but the problem is that scanf, it actually tokenizes your input. Tokenizes as in it splits your input whenever it sees some white space. White space means space or slash n, stuff like that. So as soon as it sees something like this, it actually assumes that the input has ended. With fgetters, that is not the case. Fgetters will only stop taking input when it sees a slash n character. Okay, it doesn't stop by seeing a space character. It only stops with a slash n. So if you take input through fgetS, it will take the whole string up to you, until you press enter. Everything that you entered on the console, that will be inputted. The drawback of fgetS is that it actually requires one more space than whatever you are expecting. So why? Because it also adds that slash n, whatever slash n that you press right towards the end, that slash n also gets added to your string. So if you write something like this, hello, and then you press enter, HELLO, and then press enter, your actual string will be something like this, H E L L O slash n slash 0. So this is what your string will look like. Okay, HELLO slash n and then the slash 0. Okay, so there is an additional character that fgets adds to your string. So this is a drawback of using fgets. Okay, and if you see some of the code that I have written, I actually have to remove this slash n explicitly, because otherwise the slash n will become a part of your file name. That is the problem. uh, so this is the only drawback with fgetS. Otherwise fgetS is a good function. It can take inputs from standard input. If you want to take input from standard input, uh, you just type the file pointer as std in. So this is what we have done already. If we do something like this, mm, it's std in, sorry. Okay, so then this is going, this what does this mean? When you do fgetS arr10 std in, it means go and take an input of up to 10 characters from the standard input. That is when you type it on your console. Similarly, if you do something like this, fgetS arr10 f fptr, it is the same function. It is the same function. The only thing that is different is when you're reading it from the file, you give it that file pointer fptr that you create using fopen. And when you want to use it for taking input from console, instead of giving fptr, you simply pass stdin. It is the same function. Okay, you can use it for both taking input from a file as well as taking input from console. Now you understand? The only thing that differs is the file pointer. That's it. Okay, I hope you understood. Any other queries?
So for the F right part, when we used it in the code, you used it
Mhm.
twice. So I cannot understand why you used it for the first time.
Yeah, so this is the format that I am creating for my binary file. The format is something like this. The first integer, it's similar to your competitive question inputs, right? The first line tells you the number of test cases, and then the next n, next three line will be the first test case, the next three line will be the second. That example that I gave, the same thing I am following here, that the first integer that I write to the file is the size of the list. Okay, if let us say there are five numbers in my list, first I simply write 5 as an integer to the binary file, and then I write those 5 integers, the actual list. So the total number of integers that I will write will be basically n plus 1, where n is the size of my list, and 1 because I'll write n itself as the first input. Does that make sense? That basically I'm writing the size of the list first. This helps me in writing a loop. Okay, so if I do a first, when I'm reading this file, you can see that there are two f reads also. The first f read reads the size of the list, and then I can simply write a loop I equal to 0, I less than n, and then read those n numbers after that. Okay, so just open the list reader program. It will have two f reads for it.
Sir, so actually in the file, the number of elements will also be stored.
Yes, the number of elements is also stored. That is the first input that I'm that is the first output I'm making in the file.
Okay, sir.
So now the idea is like this: if you have to store an n integer list in the file, um, I actually store a total of n plus 1 integers in the file. The first integer is n itself, right? I mean, I'm just telling that this particular file has a list of n numbers, and the value n is the first input of the file itself. It's a binary format that I have come up with. You can have a different format. You can simply say I'll just write the n integers and I will not write the size. So that clean std in is basically a kind of utility function. So the problem with C, especially when you want to take single character inputs, is that at many a times you have something left in the input buffer. So there is something known as input buffer. Whatever you type through the keyboard, it is not given to your program straight away. The operating system puts it into a buffer, and then as soon as you press enter, all of the input that you have written till now is provided to your program, and then your program parses it. The problem is if you want to take single character inputs like yes or no, it becomes a problem because sometimes the enter that you pressed last time, it remains within your buffer, and that enter gets consumed as your input, so you will not be asked for yes or no. So that clean stdin function, it simply clears your buffer, okay, so that a new character can be inputted. That is the idea.
Sir,
Yeah.
sir, what is the difference between fflush and clean the functions?
So fflush was supposed to do the same task as clean, but I actually went and read the details, the documentation about it. Fflush is not meant for input streams, it is meant for output streams. Okay, so fflush will work, let us say, when you want something to be written to a file. And by the way, when you do these f reads and f writes, the same pattern is applied. Operating system doesn't read or write stuff byte by byte. There is a buffer. Okay, there is a temporary place where things get read to or things get written to, and from there they are finally flushed. Okay, flushed as in they are finally saved to your file. This fflush function, if you want whatever is currently there in operating system's buffer to be written back to the file, then you use something like fflush. If fflush is not useful for input streams, that is the problem. Okay. There is a link, I think, in the code, link to a Stack Overflow question. Just go and read the answers to the Stack Overflow question. Yeah, sorry, we have run out of time. If you have any more queries, you can always drop an email. But tomorrow will probably be the last part of our conventional programming syllabus. Um, there will be some more assorted topics. I may or may not cover them. If I feel that you guys are not comfortable, we can take up even the next week as week after that for problem discussion. But I plan to teach you like some more C in the last week. But that will be, as I said, that will be C specific. That is not really programming. Uh, it is important because so it's like this. The operating system has certain ways of doing IO over your file, and it is a good thing to tell the operating system that I am done. I'm it is more to do with the fact that let us say you opened up a file for reading but you did not close it. Over a period of time, operating system will automatically close it, no doubt. And in fact, most uh, modern operating systems have a way to figure it out, that the program that was accessing the file, if the program is killed, it will automatically close the file. But it is a good practice to tell the operating system that I am done. because of this concurrency thing, right? That if multiple programs are trying to access the same file, there is some locking mechanism. Okay, so let us say you opened the file for reading, but you did not call the f close. Now there might be another program which wants to write that file. It will not be able to write that file until the operating system is absolutely sure that no reading is going on. So if you do the f close thing, it's a good thing to do. Okay, otherwise the writing program may have to wait longer than it should. That is the idea. You'll read more about read write stuff in operating system. Sorry, I keep on telling you stuff from other courses. Okay, so guys, we'll meet tomorrow, right? And on Thursday we'll have the lab from 4 to 6. Okay, bye guys.